Okay, so yesterday I wasn't here, but I did some planning, and I'm looking at the rest of the quarter, and so provided we don't have any more snow days, which at this point in time, who knows, we will have formatives on the 3 Tuesdays that you have left in the third quarter. Okay, so formative every Tuesday. We will have quizzes and the test on the 3 Thursdays of March. Okay? So, and then the reason that we're testing on the Thursday is because then Battle Royale is on the Friday before spring break, and the first class wouldn't meet. So, okay? So that's where we stand right now with it. Granted, I know that things will probably change because we might have a snow day. You never know. I would hope that we're done with snow days by now, but I don't hold my breath at anything anymore. Okay? So with that being said, we will be in chapter 12 for this sequences and series unit, if you will. The one thing that I will tell you that I will warn you about right away is that I don't have time to have a review day scheduled in this unit. Okay, so there won't be a review day, then the test comes the day after. Okay? We don't have the days anymore. And we just don't. So you'll get the review assignment early in that last week, and then you'll have to be working on that while you're still learning the stuff. So just so you know, it's just one of the casualties of, where are we at now, 7 snow days. So. What was that, by the way?
The thing you just handed back.
Oh, okay. I didn't know if it was a review assignment, or I was going to say if it was, you needed some graphs, but it's not. Okay. Alright, so sequences and series. You've seen them before. You saw them in Algebra 1. You saw them in Algebra 2. Okay. We're going to expand upon that knowledge again, because this is I've broken up this chapter into 3 basic parts. Okay? The first part is arithmetic sequences and series, which will start tomorrow. The second part is geometric sequences and series, which will start next week, Friday. And then infinite geometric sequences and series, which will start in 2 weeks. Okay? All right? So those 3 basic parts. Today, though, we got to get you thinking back about what a sequence and what a series and all that stuff is. Okay? So, a sequence is a list, is really what it is. It's a list of patterned numbers. Okay. So there is a pattern that goes on with your list. And the list is written with commas in between. Okay? So we write the individual number, and then a comma, and then the next number in the pattern, and then a comma, and then the next number in the pattern. And those individual numbers are called terms. Okay? So the domain of a sequence or series is the term number that it is. Okay? So if it's the first term, the domain would be 1. The range would be what the actual terms are. Okay? Now, we are going to assume, unless otherwise told, that the first term is term number 1. Okay? Unless we're told otherwise, the first term, the first number in our sequence, the first number we would write down, we're going to assume that that is term 1 unless we're told otherwise. That is in fact term 7 or term 9 or whatever it is. Okay? We're going to assume that that's the first term unless we're told otherwise. Okay? There are things called finite sequences. A finite sequence has a limited number of terms. And so the way that you can tell a finite sequence is that at the very end is a number. Okay? So I could continue on with this pattern here, signifying with dots, but as long as I end with a number, it's a finite sequence. It's an infinite sequence if it ends with 3 dots. That signifies that that pattern will continue forever and ever and ever. Okay? And so then that's an infinite sequence. But if after the 3 dots there's another number or 2 more numbers or however many more numbers, then it's a finite sequence. It's all about how it ends. Okay? When we're going through and we're finding patterns today and in this unit, and we're finding what that pattern is to make that sequence be true, we call that pattern the rule. Okay? So we call that pattern the rule. Okay? Now, if I give you a rule and ask you to find the sequence, that's one style of problem. Or another style of problem could be I give you the pattern, or I give you the sequence and ask you to find the pattern. Okay? Or I could give you 2 terms in the sequence and ask you to find the rule. And things. There's many different ways that we can go with problems here in this unit. So one way is, here's a rule. A sub n is equal to 2n plus 5. Or here's another rule. F of n equals negative 3 to the n minus 1 power. And I want you to find the first 6 terms of the following sequence, or of that in particular sequence. Okay? So what this is asking for is a sub 1. So you're going to put 1 in for the variable. The variable in these rules is n. So you're going to put 1 in there and figure out what the first term is. 2 times 1 is, plus 5 is 7. So the first term in this sequence is 7. We assume to be 1, unless we're told otherwise. Okay? To find the next term, we take the next integer. So what's an integer again? Even more specific, because 3.2 is not an integer. It's a whole number. It's a number without fractions or decimals attached to it. Okay? So it's just the whole number. So we take the next whole number in line. Well, what's the next whole number after 1? 2. So we're going to find next a sub 2. Two times 2? plus 5. Then we have to find the next one, because we need to get the first 6 terms it told us. So we have to go to the third one then. Two times 3 plus 5. Now we got to go to the fourth one. Two times 4 plus 5. Next one. What's the fifth term? 15? 2 times 5 is 10 plus 5 is 15. Sixth term? Okay. So we showed all of our work, finding all of our terms. Okay. Now, to list out, to write out that sequence, then now I've got to start with the first one, and the first one again was 7, comma, 9, comma, 11, comma, 13, comma, 15, comma, 17. And that is my list, or my writing out of the first 6 terms. I have to write it with the commas in between. Okay? I'll say that again so that you understand that if you gave me the blue and said that's my answer, how you're wrong. Okay? You have to write out a sequence with commas in between the terms. Okay? If you don't, you haven't written it out. You've just done the work. Okay? All right? Let's go to the next one now. So now, instead, because now here I'm in rule notation. In number 1, I was in rule notation. Okay? In number 2, I'm in function notation. F of n now makes my rule be -3 to the n minus 1 power. So now, instead of finding a sub 1, now I'm going to find f of 1. And that's going to be -3 to the 1 minus 1 power. 1 minus 1 is? -3 to the 0 power is? 1. Then I have to go and find f of 2. Two minus 1. -3 to the first power. Then I got to find the third one. What we got there? Third term. -9. Sure about -9? +9? Okay. 3 minus 1 is 2. -3 times -3 is +9. Fourth term. Negative 27. Fifth term. $81, positive, right? Yep. Sixth term. Negative 243. So the first 6 terms of this sequence are 1, negative 3, positive 9, negative 27, positive 81, negative 243. Find me the first 6 terms of those 2 sequences. So I get the first 6 in the first one are 2, then 0, then negative 2, then negative 4, then negative 6, then negative 8. Now, when in doubt, you definitely want to leave stuff in terms of fractions, because it just makes it be a much cleaner, much nicer sequence. So this one then became, the first 6 terms are 1/2, then 2/3, then 3/4, then 4/5, then 5/6, then 6/7. Okay. Now, it's all nice and good when they give you the rule, okay? But that's not always going to happen. Sometimes they're going to give you the sequence, and then they're going to ask you, them being me, are going to ask you to, 1, describe the pattern. That is in words. Okay? So you have to describe the pattern. You are subtracting 2 every time to get the next term. That's describing it in words. Multiply by 3, describing it in words, etc. Okay? So that's the first thing. The second thing that most of the time they will ask you to do is write the next term. So that is going to be an actual number, because it's going to be the next term. And then lastly, it will ask you to write a rule for the nth term, and that is going to be an equation. So there are three parts to these type of things that they could throw at you: the book, the tech, myself, in terms of they. Okay? All right? So first thing you got to look for is you got to look for the pattern and see what's going on with any particular problem. Does anybody see in number 5 what a pattern might be? The pattern that I see is that it is the negative cubes. One cubed is 1, negatived is -1. 2 cubed is 2, two cubed is 8, negative is -8. 3 cubed is 27, negative is -27. 4 cubed is 64, negative is -64. So that means that my next term then would be 5 cubed and then negated, which would be -125. Because it would be the 5th term. A rule for that then would come out of how I figured out that next term. And so here I would say, I'll go function notation, f of n is going to be negative of n cubed. And that's my rule. Okay. Number 6. Anybody see a pattern? So we could say here that this is adding consecutive even numbers. Started by adding 2 to get the first or the second term. Then we added 4. Then we added 6. So then we're going to add what to get the next term? 8. So 12 plus 8 is 20. Now, a rule might not be the easiest thing to do, right? Because we're always changing what we're adding. Okay? So a rule here could be, and this is by no means the only rule, okay? The nice thing about these is as long as your rule works for every single term that's listed, it's a rule. Okay? It all doesn't have to look the same. Likewise, your description doesn't all have to look the same. Okay? I could have said here for a description that the term is the term number squared minus the term. Okay? Because that's actually what the rule is. The rule is n squared minus n. 1 squared minus 1 is 0. That's my first term. 2 squared minus 2 is 2. That's my second term. 3 squared minus 3 is 6. That's my third term. And so on and so forth. Okay? So it might take you some time, but as long as you find a pattern that works, you're good. Okay? And it's got to work on all of your terms. If it only works on 2 of your 3 terms or 2 of your 8 terms listed, that's not a rule. Okay? That's not a rule. Sequences become series when we add all the terms together. So if I had a sequence, like for instance, I'll take the very first one that we came up with in number 1. It was 7, 9, 11, 13. So in sequence form, it was 7, 9, 11, 13, 15, and 17 was my sequence. Okay? The only thing different now in the series is that instead of writing commas, we write addition signs. Okay. And then in a series, we can add all of those numbers together and get us one answer. So the sum of the series here would be, what is that, 24, and then 24 is 48, and then 24 is 72. So if I added those 6 numbers together, I'd get 72. Yeah? The new part in series notation is something called sigma notation. And sigma is the Greek letter that looks like a fancy E. Oops, that one's not the best, but went too far. Yeah. So it looks like a fancy E. Now, to put something in sigma notation, you need 4 things. The first thing you need is you need a variable. Okay? You need to have a variable. You got 26 choices to choose from for the variable. Okay? The second thing that you need, excuse me, is a starting value. Okay, so you need a number that you're going to start plugging into something. Okay? 9 times out of 10, it's going to be 1. Okay, your start number is going to be 1 because that's going to give you that first term. Okay? Then you need an ending number. It's going to tell you where to stop plugging numbers in. And lastly, you need a rule to plug those numbers into. And your rule there is going to be in expression form. It's not going to be an equation. Now, there's fancy words for all of that. The index of summation is your variable. The lower limit of your summation is your starting value. The upper limit is the ending value. Okay? and then the rule is just the rule. Okay? All right. So let's work on writing the series using summation notation. So the first thing that you should find is you should work on finding the rule. Okay? So in order to find the rule, you should figure out what the pattern is. So what is the pattern for this particular number 7? Adding 25? Okay. I would agree that every time you're adding 25. Okay. Based off of that, can we come up with a rule for this series? If n plus 25 were my rule, my first term would be 26. My second term would be 27. Third term, 28. You understand what I'm saying? Because if I go with my rule here as n plus 25, then when I plug in 1 there, that gets me 26, and that's not 26. So your rule doesn't fit your series, just so you know.
25N.
Okay? What you got, Henry?
25N.
Does that fit the first term? Yes. Does it fit the second term? Third term? Fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 11th term, whatever term 250 is, right? Okay, it would fit. Because we, okay? All right, so that gives me my rule. So I like that rule. It fits all my terms. Okay? So, a starting value then. What was the first number that I plugged into, or what number do I plug into my rule to get my first term? 1. So my starting value is 1. Ending value. What number do I plug into my rule to get 250? No. What do I get? What do I plug in to get 250? What? 10. Yeah, 1. You know the rule. No. I don't have a thing that this goes into. What'd you get, Sam? 10. Okay. So 10 is going to be my ending value, because if I put 10 into my rule, I get 250. Okay. So, sigma notation for this particular one. Sigma notation is going to be, actually we'll put it in black this time. Okay, so I start with my sigma. What variable do we want to use? 26 to choose from. B. Okay, so we're going to say B equals 1, because that's my variable. My variable was B. My start was 1. What's my end going to be? 10. And what's my rule? No. 25B, because I got to have my variable. Yep. Okay. And that's the sigma notation that goes along with it. Okay. Had we chosen n as our variable, yes, then we could have done 25n. Or if we chose q as our variable, we'd have to go 25q. Okay? Got it, Colin?
Yeah, how do you get 10?
because my rule is 25n, right? My last term is 250. So n has to be 10. Okay? Right? You try number 8. I don't remember which one it was, but it was one that we did already. Four. Where does this one end? It never ends, right? So what do we call that in math? Infinity. So it's going to end at infinity. So this is an infinite series. Okay? So sigma notation here then is going to be variable. What do you want to choose? N. Okay. N equals 1 to infinity of n divided by n plus 1.
So if it has a dot, dot, dot at the end, it's always going to be infinity on top.
Because it never ends. Yep. Now if it had dot, 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 and then another number, like in number 7, then it's not infinite. Okay. Now, this question is asking us to find the sum of this particular series. So, in order to find the sum of the series, we have to find the series. Okay? So, this particular one, it chose I as our variable. So I'm going to start at 1, and I'm going to put 1 into my rule. 8 times 1 is 8. Then I'm going to go to the next integer. So now I'm going to go to I equals 2. And I'm going to plug that into my rule. I get 16. Then I go to the next integer. Plug that into my rule. And I get 24. Go to my next integer. Oops. Go to my next integer. Go to my next integer. Yay or nay? Why not, Logan? It says stop at 5, so I can stop when I get to I equals 5. Yep. Okay. So the series here is 8 plus 16 plus 24 plus 32 plus 40. And now I simply just add those numbers together. 8 plus 16 is 24. Plus 24 is 48. Plus 32 is 80. plus 40 is 120. And so the sum of this series is 120. Okay? You find me the sum of number 10. Uh, 23 plus 24 is 47, 77, 82, 90. I get 130. Yes? Homework for tomorrow. We're going to do multiples of 3 tomorrow, or 4 in class tomorrow.